Okay, round two. Hello, everyone. Welcome to wasmCloud Wednesday. This is the meeting for April the 27th, and we have a couple of different exciting demos to start off with today. I think I know of three at least, so I'd like to go ahead and hand it off to, let's see, Taylor, are you ready with the pet clinic demo?
Yes, sir, I am. It only matters if Liam has granted me his awesome privilege of screen sharing, so we'll see what happens. Oh, yep, host disabled participant screen sharing. Oh, there we go. Thank you, everyone. Welcome to a normal meeting of wasmCloud Wednesday, where Liam does not give us screen sharing permissions. Okay, let's share now. Let's see. Make sure I do this right. Okay.
It's part of a broader plan.
Yes, it is. Liam's plan to take over the world by screen sharing permissions. Maybe we should write an interface for that. Anyway, so this is the wasmCloud dashboard, as you all know, our favorite washboard, but that's not what I'm here to demo to you today. So what we did recently, if you didn't see our blog post, which hopefully Brooks can maybe help me out and put that in the chat. We were tired of having to have people host the UI as like a Docker container and all that, and figured let's just figure out how to do this, because we know the way you can host a UI is varied. A lot of people will do this like with a CDN, but sometimes there's things when you're doing smaller projects or internal types of things that are not behind a CDN where you might want to serve up your UI, and now you can do that inside of WebAssembly. This wasn't like a new feature we added to WebAssembly. It's just showing you how you can do this. And so what we did is put the whole thing inside of a wasmCloud actor, and let me show you what that looks like. So you'll see, if you've seen the pet clinic example before, you will have probably seen that there was a separate interface part. Well, that's now been added to this UI actor. Now, the UI actor is this hybrid of HTML, CSS, and Rust. So what actually happens here is we have it set up. It uses the node build chain for like an npm build type tool chain to build everything up. But we do that all for you inside of the build.rs. So what I'm showing here is the pattern of how you could do this on your own. And it's just one of many different patterns you could do. You could implement this with a backend blob store or some sort of other thing. This is just the simplest solution. And so here we actually do a like npm install and an npm run build, and then we're good to go. So this will do it when you build, and that compiles all of your assets into a single static asset package. And then all we're doing is not there inside of lib.rs for the actual actor. We're creating this folder. We're creating an embedded folder that pulls in the data that was compiled and makes it so that you can embed all the assets in the actual binary. So obviously this is going to make your binary size a lot bigger than a traditional wasmCloud module, but it has the advantage of having everything put together. And so this does a very simple, straightforward thing. It just assumes that if it gets something, it's checking from the root path, and then tries to fetch data from the root path. So it's just a very simple like file server in a sense, and it will send it back. Now, we mentioned a couple of weeks ago that we added some automatic chunking support on the backend. So now when you send big requests across a lattice, they automatically get chunked and dechunked in their environment. And this takes advantage of that. And so what it does is now we have an actor that the API gateway will now just fetch the data from there. So if this assumes some familiarity with the pet clinic example, but the pet clinic has an API gateway, which everything flows through. It's the thing that's connected to an HTTP server. And in this case, we just added something new. In this code is just going to fetch a path from the UI and send the data back. It'll attempt to set the content type as well and send it back to the sender. Now, what this allows us to do is now you see this UI that's running, the pet clinic UI, and I can just go to localhost 8080, and you'll see that the whole UI loads. It's still loading stuff and data from the back end right here. I could add an owner and stuff. We're not going to do that right now, but this UI is being entirely served by that actor. There's some cool things you could do with that. For example, if you really want to push your UI assets close to the edge, you could send these all the way out to an edge device that's connected to your lattice. And like I said, there's a million other ways you could do this. You could just have like one thing be the part that serves your UI and have it connected to the HTTP server. It doesn't really matter. But we just wanted to show a concrete example of how you can do this by embedding your assets inside of it. So That is all I have. Are there any questions? I have to drop right after this, so this is your time to ask the questions if you have them.
Taylor, what do you think is next? Should this be generalized as like a pattern or a framework where you can just take a set of static assets and then have something that pulls them in, or what do you think would be a good path for exploring after this?
So I think that we're going to have to see how people want to use this. I do think there is an argument to be made for this UI interface, which is what I'm using for the actor to actor call here. I actually think this kind of like get asset thing could be a generic crate we publish. It's going to be super small, but it basically is defining that operation. So maybe we can make this an actual publicly supported interface, but we want to see how people use this, because it could just be a toy that people use for simple API stuff or toy projects, but not for bigger projects when they're actually implementing it. But the idea is just to show more and more. You'll see more and more of this from us maintainers, is that we're trying to show how much we can push the boundaries of WebAssembly right now, even with some of the gaps that still exist. We want to be able to push that further and further. And so we're going to start showing more and more of these things that we do entirely inside of wasmCloud rather than leveraging other technologies like Docker. So that's what I personally see as the future with this. There was also a question from Janatha about, is this a file server? In the strictest technical sense, no, but yes, it is a file. It's acting as a file server. So it's requesting a specific asset and it's just loading it from something that's embedded inside of its inside of the actual module, the bytes that have been loaded into memory. So it pulls that out and sends it back. So that's just one of those things that, like, it is essentially acting as a file server that's behind an API gateway of some kind. Let's see in chat here.
Sorry, I need to unmute myself there just for a second. I've tried to do this before with some Dropbox hack at some point in time. And I think I ran into trouble with like dynamic content, and I'm not entirely sure what I mean by that, but are there limitations to this approach, I guess, is what I'm after, in terms of, like, it would seem that like a static HTTP page, for example, will be fine, but if something's really heavy, JavaScript with things running around everywhere, that it might be a problem, especially if you're, I think my head is actually at like cross-site scripting or asking for different inputs from different sources.
So it just depends on what you're doing. Like, for example, we couldn't do like a PHP or something on here like that. That wouldn't work if that's what you're referring to with dynamic content. But anything that's being done on the browser side could technically be hosted here and served out. Just like I said, the major downside of doing it this way is you're going to balloon the size of your actor. So your actor is basically going to be the total size of your application that it's going to be sending to a user, plus the extra bits and bobs for actually sending that data from Rust. And so it's going to expand your size. And obviously that might not be worth it, especially if you're pushing to edge devices as the UI size gets bigger. So that's something that would definitely be a downside here. But like I said, there's a couple different options. Yeah, and Kevin actually mentioned this in chat. Like, this doesn't do any compression. We could easily do some compression. And I know that, like, for example, the Rust embed crate has a flate thing, so you can actually do some compression before it actually embeds the file, and then you can embed that compressed file on the way out. So we haven't done a huge amount with this. This is just the super like dumb pet clinic API. There's not a lot to it, but I would love to see if anyone does this with like a more advanced UI and just see what kind of things we run into, because we'd love to work through. If you find any bugs, just work through them, figure out what we're doing to like make that actually work. And you can see like the lessons we learned even from doing this in that blog post that Brooks linked. So hopefully that somewhat answers it, but it depends on the type of dynamic content, but it should be able to handle it to a point, and then it might become a little unwieldy.
Follow-up question is, Brooks might have mentioned last week that he had like deep insights into WebAssembly and that this helped you therefore. Is there like private functions here that you expose, or is this all kind of public stuff that you are able to glean from documentation, so to speak?
this is all public. I did nothing super fancy with WebAssembly here. What you see in the, like, if I go back to the actors here, this is literally all the code. Like there's nothing else. It's 52 lines of code, and 10 lines of that is like defining structs and imports. And so there's nothing special here. This is just doing a normal WASM compile. And I think this exact example should work as is, even as we start supporting WASI based actors, which is something we want to do here soon. And so all these kind of things I think just work. There's no special import export trying to glue things together. It just works within the wasmCloud model. Great questions there. Any other questions before I stop this and have to drop?
I had a quick clarification, Taylor. I know you mentioned that we implemented chunking in the host. Why did we have to? Can you talk about like why we had to implement chunking for this to work?
Yeah. So the thing with chunking is where the lattice is NATS. It's backed by NATS, and when you're using a message broker, there's clear problems with sending very large message sizes. Not only does NATS discourage it, but that's just generally a bad practice. And so what we do is to make it a lot easier to stream through, especially for things like blob store, which is one of the first things we implemented this for, is you want to be able to basically create a streaming API. And so this allows you to get streaming chunks back. And I can see us actually in the future improving things like the HTTP contract and at least the HTTP provider to do like streaming responses if it knows its chunks. That's down the line, but there's a lot of optimizations that can be made here. Because all that, especially for UI type of stuff, all that matters is that the page is able to start loading fast, and streaming API is going to allow you to do that somewhat quicker because you can start immediately processing things as they come in. And even if it's technically a little bit slower, there's that little like tiny bit of overhead that happens from using like a distributed system like this. Hopefully with a streaming API, that's pretty much negated from a actual user interaction standpoint. And so that becomes very valuable to have. And so this makes it so it's just transparent. You notice I did nothing in this code that has anything to do with chunking. It did it all for me and streams it out to where it needs to go.
Very cool. Well, yeah, does anybody else have any questions for Taylor?
And if there's any other questions since I have to drop, please feel free to reach out to me on the wasmCloud Slack or any of us. We put this together, so it's a pretty nice little example. And if you liked what we did here, please do share the blog post. We have been trying to make sure we're posting more of exactly what we're doing. And so having those out there will really help show people what we're able to do and stretch with wasmCloud and hopefully encourage others to do it. So just reach out if you have any questions.
All right, well, with that, we'll move on to our next exciting demo, which will actually be given by yours truly. I'm going to give the second of 3 demos today. So to bring you through a little bit of the narrative coming to like this feature that I want to show off. Every once in a while, we come back to our initial user experience for running the first wasmCloud actor and getting that running and working with it and iterating on it. And we try to find any points of friction and see where we can improve that. So I'd like to kind of revisit that today as a part of this demo. So I'm in this little temporary directory, working off of a newer version of Wash. And I want to show what it looks like to generate your first actor. We have the wash new actor command. This is what pulls from our project templates repository. We'll generate an actor project for you, like with all of our scaffolding and a helpful make file to get started. So when we do this, and I'll go ahead and I guess get this running while we wait. We get essentially this actor. This is a very simple HTTP server actor. It has a single handler for handling a request, takes in an HTTP request, gives back an HTTP response. It's like our hello world demo. And by default, running like make in this actor project will build and sign the actor for you with the HTTP server capability. So this really, this takes away a lot of the initial friction of writing your first WebAssembly module. We'll compile it to WASM for you using your cargo toolchain, and then use Wash, which you already used to generate this project, to go ahead and sign it. Now, running this for the first time, and you all should be able to see my browser. Running this for the first time, you'll launch NATS, you'll launch a local host, start up HTTP server, and then from file, you may come in and start the hello actor. And once you do this, you'll link the hello actor to the HTTP server. And then if you do something like curling localhost 8082, you'll get back hello world. So this is like the initial example for running a wasmCloud actor that can act as an HTTP server and handle requests, our hello world. Now, going forward on this, if you iterate or want to develop this actor, you could use our hot reloading feature so that when you are making changes to the actor, we're essentially loading this from your local file system so that every change you make will automatically reschedule it for you. But as soon as you make it off of your local file system, you're starting an actor from an OCI compliant registry. And a lot of our examples do this now. What we'll do is we'll launch the local Docker registry or the registry image. It's a Docker container, and that works for pushing WebAssembly modules too. So you'll use our make file, like a make push script, to push it to there, start from an OCI registry. But we still have the problem of, as soon as you make it off of your local machine, there's no real way for you to access this actor. You have to then go set up your registry. You have to go make sure it's open to the public, which I think even for our wasmCloud Azure Container Registry, we had to like open a ticket with them so that it could be public HTTPS, but anonymous authentication. And so I have a couple of improvements to that flow today. So thankfully, something called GitHub Packages exists, also known as GitHub Container Registry. And I just want to thank Jordan for going out, and Jordan Rash is on the call today, for going out and actually testing that Wash could push to and the washboard could pull down from GitHub Container Registry. And I want to show you what it looks like to push to this registry. It's already configured, it's OCI compliant, and I think it's a pretty nice workflow for developing wasmCloud actors, and especially just to get it out into the world. So what this looks like from the GitHub perspective, we can create a repository to put our actor in. And I'm going to use hello, even though GitHub thinks that ideal broccoli would be a better example. So this is all you pretty much have to do from the UI side. We just need to create a repository so that I can push to it. Now I can go ahead and add in all of the actor files here. Basically just copy and paste all the things that GitHub gave me here, and we can create our actor repository. So these are all the things that are in, auto-generated for us with Wash. Now, in order to publish to GitHub Packages, if you follow through their little, if you follow through their UI, it's a little unclear on how to actually get there. It's recommending things for containers. It's not really like WebAssembly hasn't really made it into the GitHub tutorials yet, but it's actually fairly simple. And this is supported now with Wash. So the process after you've built, and let me extend this a little bit. Once you've built and signed your WebAssembly module, which is automatically done with make, you can use a wash reg push, which is how you're interacting with an OCI registry. I'm authenticating here with like my username and a GitHub personal access token. This is probably better done with an environment variable, but I'm just showing you everything here. You can push to GitHub Container Registry at your username, and then you can tag this package however you'd like. So I call it hello just for simplicity. We give our WebAssembly module, and then one special thing the GitHub Container Registry looks for is an annotation. This is something at like the OCI manifest level. And we can basically tell GitHub Container Registry to associate this artifact or this package with this repository. So we do this, we use wash to push to GitHub Container Registry. This is the same actor that I just started from a file. And once we do that, if we come back to our repo and we hit refresh here, you can see that we have a package, our hello package. And if you come, you can see our recently tagged version, a README for this. This will actually show up under my profile as well. But this actually right now is a private package. So this is just for me to consume. That's pretty easy to change if you wanted other people to be able to access your actor. I can just change the visibility. And then as soon as you do that, you can come back here. If we come to our wasmCloud dashboard and we go to start an actor from a registry, be kind of the wrong thing, but let me grab the correct one. Here it is. Go back to start an actor from a registry. We can actually get that hello actor directly from GitHub Container Registry. And then if we do that same kind of curl that we did earlier, we'll get hello world. Same thing, just started from GitHub CR. Now the workflow for continuing to build on something like this, if we wanted to change the response body of this to be something like hello, there we go, hello GitHub CR, or something like that. You iterate on your HTTP server. We can run make. Once that builds, we can then push to 0.1.1. If we come back into our wasmCloud dashboard, we can use the from registry feature to start 0.1.1 as soon as it pushes. Okay. Now that we do that, if we do our same curl command, we get hello GitHub CR world. Just showing that we can make a simple change. And our package here will actually show the recently tagged image versions, and you can look at the digest and everything here. Now, I'm going back and forth and kind of manually pushing to GitHub Container Registry here. Just to start, the benefits of doing this, to have an already configured OCI compliant registry is huge. Definitely useful for the development process and for when you want to distribute your actor to the outside world. But second, there's a really good opportunity for us on the wasmCloud side to integrate those actions as a part of the GitHub or as a part of the project template. So you say wash new actor, we can generate a GitHub action for you that will, when you push to main, build, sign, and then release your actor to GitHub packages, so that the flow is, we're essentially packing in some pre-configured CI/CD for you, right, to build, test, and release your actor. And our goal for this isn't to make it so that you develop through GitHub CR. I think it's still better to do the local development, a hot reloading style example, but this moves us more in the direction of making it accessible and easy for people to publish actors so that they can be accessible publicly. So that is, let's see, I think that is all that I wanted to show off today. Does anybody have any questions about GitHub Container Registry or this flow, or does anybody have any comments? Have you worked with this before and have ways to improve this? All right, sweet. Well, so this, the new version of Wash that I'm using, 0.11 and alpha release, is just to have that annotation. You can actually do this in with the latest stable release of Wash now, but that annotation automatically associates the package with the repository. So it's definitely nice to have moving forward. Once we do the work on the GitHub action, I'll probably demo it in a community meeting, but I'll definitely put it in our community Slack and ask for feedback and some beta testers, because it can really, I'm looking forward to get some feedback on that. All right, second demo of the day done. And thankfully we're not done yet. We have one more exciting demo. Liam, did you have a thing? I saw you came off mute. Okay.
No, it's awesome. I think you should just write that up as a blog post. That was, I think that's super helpful, just to take your lessons learned about how to do it with WASM, and let's get that out there.
I like that. So yeah, we have one last demo today that I know about, unless somebody's going to come up with a surprise demo. I think I'll hand it to Jordan to show off. Jordan and Kevin are probably gonna talk about our TinyGo support in wasmCloud.
I can't share anything.
I swear other people have permissions to delegate that.
I think at this point it's just built into the Zoom product itself that Liam can't delegate permissions.
You're on the invite. You're an admin if you log into Zoom.
I am logged. I don't know. So hello everyone. I am more or less Kevin's assistant today because he had released something really awesome that he mic dropped at the end of the meeting last week, and I think it's worth sharing. But I'm going to let him talk through it. More or less, what I've done for you, Kevin, is I've just pulled up the whole process and curled it, and the code's here. And if you want, I can actually pull up just the GitHub page for you if you want.
Yeah, the GitHub page might be easier. Just it might be a little bit easier to read. I don't know. Maybe it's just my screen that's having trouble seeing yours.
No, I recently got this big old monitor, and I don't know what it looks like. All right, so there you go. Is that better?
Yeah, Brooks. My mother always said I had a face for radio. Yeah, I'm on a Mac today, so maybe that's why my voice sounds so much better. It's so yeah, last week dropped a little something in the meeting, and what it amounts to is that we have regained support for building actors in Go. What you're looking at is just an example of what a Go actor looks like, and right now it's fairly clean, but we'll have it even more clean once we get the code generation stuff in place. The code generation stuff gives us the ability to have, strongly typed message handlers rather than handlers that just deal with slices of bytes. So that'll be an improvement once we get the code gen in there. One of the things that Jordan ran into that you are likely to run into is that if you breathe on TinyGo just the wrong way, you will incur a dependency on the syscall.js package. And when that happens, the WebAssembly module that TinyGo builds attempts to import a bunch of stuff that only exist in the proprietary JavaScript library that is used on the server side for Go stuff. And so, yeah, those imports, like if you look at those, that is a Go specific import that is only ever used by Go libraries that are running in a browser. So if you look at your imports when you're building these modules and you see that you've got syscall.js stuff in there, you can pretty much guarantee that it's not going to work in wasmCloud host. And there's some philosophical reasons for that, but by and large, what it amounts to is the wasmCloud host supports nothing but the base WebAssembly spec and freestanding WebAssembly modules. So it doesn't play nice with modules that are making assumptions about the host runtime. And Jordan, I forget which package you used. I think it was embed that auto imports syscall.js.
So yeah, I pulled down Go, all of it, and did a quick search through, you know, a quick search for just syscall.js, and there are 3 major libraries, and the one big problem is time calls it in, and then time is called in by everything.
Yeah, and
So it was,
that's
yeah.
that's unfortunate too, because you know one of the core tenets of a freestanding WebAssembly module is that it never attempts to access a wall clock. And so as soon as you start pulling in the time libraries or things like random number generation, then you're already outside the scope of what WASM can do. Rust actually makes it a little easier to get around that, where you know, Taylor showed me a trick where you can actually replace the default attempt to get a random number in Rust with the random number wasmCloud built-in library. It's not quite as easy, if not impossible, to do that for TinyGo. So I guess our strategy going forward is just try and be as diligent as we can about not incurring the syscall.js package. But every time we do, we need to bring it up to somebody within the TinyGo team that's responsible for the WebAssembly support, and keep pointing out all of the ways that it violates the freestanding rule.
So real quick, Kevin, I'm in Go, I think Go Master, which is like Go 19, which isn't released yet. You won't see time because I'm doing some experimenting on my own, but the other 2 is crypto random and then net HTTP. They both call in syscall.js as well.
Yeah, I mean, the good news though is that if you're using wasmCloud's HTTP capability provider, then you don't need to import TinyGo's HTTP package. Same goes for things like random numbers and whatnot. So at least in these early days, we should be able to get around some of that stuff with just a little bit of diligence in terms of how we write our libraries.
Absolutely.
So Kevin, I had a little bit of a clarifying question thing. Earlier you said that, you know, wasmCloud kind of supports the base standalone WebAssembly spec.
Yep.
And that's a feature, not a bug.
Correct.
Right.
Yeah,
And
we make that choice deliberately as one of the opinions of the framework, and that's specifically designed around the idea that we want to maximize portability. If we were to support any of these one-off type environments, then we would violate the portability of the actor modules, and the actors need to be able to run, you know, on the wasmCloud host, on a server, and Raspberry Pis, in browsers, and everywhere else. And we can't do that if you know, certain modules only work on certain servers.
yeah, that makes sense. I just wanted to point that out because I know that we've made the design decision to support the most general case, same thing we do with WebAssembly engines as well. So this morning, when Jordan, you were kind of poking around at this and looking around, I went into the Gophers Slack. They have a TinyGo channel there, and was looking around to see if they have any workarounds for stuff like this. They do have a WASI target for TinyGo, and so part of that will take all, you know, some of the assumptions about accessing the syscall.js library and move it to the WASI ABI. So that's a potential path forward once we're looking at adopting WASI support and replacing wasmbus. But it seems for now that generally there are a lot of Go libraries that make the assumption of if you're running in a WASM compilation target, that you're going to be running in the browser. So, these are just I really wanted to bring it up in the community meeting, and I think it's important to talk about that because that affects how we're adopting additional languages going forward. Assuming that you're running in a browser context is something that is a difficulty, and a lot of languages do this and are moving towards adopting a more platform agnostic way of running WebAssembly.
Yeah, I mean, one of the things is that it really just comes down to the fact that the Rust ecosystem has had several years of support for compiling without a standard lib. And so that all the tooling, all the dependency management, all that stuff is literally years ahead of where TinyGo is in terms of no standard support.
Yeah, that's awesome. And this is another, great set of lesson learns that I wish we should probably try to capture as a blog post again. Yeah.
The blog post.
Kevin, I think your post on your point around the wasmCloud actors are a way to use Go without running, shooting yourself in the foot here with HTTP, I think is a great point, because that's something that I think highlights the power of our model and what we're doing here.
All right. Well, I think that calls it for demos today. Anybody else have a demo that they wanted to show off? Justin claps, but I assume that's not for him doing a demo. All right. Well, I think that moves us on to the community section of the call. So I have a couple of different exciting community things that are going on in the wasmCloud world and just Wasm in general. One thing that we wanted to celebrate, which we actually hit last week, is we just hit 500 stars on the project homepage on GitHub. And we got 100 stars on the OTP runtime, which we're really excited about. Shows some of our community growth and engagement here. And we just wanted to call it out. 500 isn't exactly Kubernetes, but it's an exciting milestone for us, and really exciting to see people interacting with the GitHub across all of our different repos. The next thing that I really wanted to, yeah, Kevin, good. It's not star quantity, it's star quality. We have the most quality stars on all of GitHub. Next thing that I wanted to bring up, and Kevin, you can probably talk a little bit about this as well. We have an API reference that we're PRing into the wasmCloud dev site. You can think of this PR essentially as like an RFC, and I'll put it in the chat now, but this is around the API reference for the application deployment manager. Kevin, do you want to talk about this a little bit?
Yeah, I mean, if you scroll down a little bit on the PR, you'll see that, no, not in here, not in the content, but yeah, the netlify/epic wiles. If you click on that, and then go to reference, and then wadm, and then API reference, you'll see it. It's much easier to read there than it is as a Git diff. But the short of it is this is basically just a straw person RFC where we would love for some community feedback on this API. And by API, what we're really talking about is designing the interaction pattern between consumers of wadm and the wadm agents. And so this is things like storing models, getting and retrieving models, deploying application specs, and getting status and things like that. So this has a couple of beneficial side effects. One of them obviously is we will be able to refine the API through a feedback loop, but another is that sort of the API/contract driven development, where if we refine this API, then we'll sort of already have a good idea of how the actual implementation of this stuff is going to work.
Yeah, so anybody who has comments, I linked the PR in the chat, and we can also re-socialize that in Slack as well. Anybody has comments, feel free to leave them on this PR. We'll keep it open for a few days while we let anybody in the community review the API reference, leave any comments, questions, or concerns, etc.
Kevin, I've kind of stopped dwelling on that for a little bit on wadm because I didn't actually know how to handle reconcile on a new specification and what we want to do there and what messages we actually want to send back and forth. I haven't really spent any time on it, and I know there aren't any check-ins or commits since January 13th.
Yeah, it's been a while since we've actually done any real implementation work on it. I'm planning on getting a little bit of that stuff moved forward this week. In terms of what we were going to do in response to a new application spec, my current thinking around it is that the reconcile step would just immediately issue all of the commands that it thinks are necessary in order to bring about that right state. Probably won't know whether that's the best approach until we implement that and poke and prod it and see how it works in real life. I think the main concern around pushing a new spec versus updating an existing one is how long it takes to go from new spec to having all of that stuff fully deployed. So there's a balancing act in terms of how you schedule the agent update interval versus how long you want to wait for a new spec to be deployed.
Yeah, I'm following on from that. The commands right now don't actually have a parser that talks out to the equivalent of, I think I mixed up this name over and over again, but basically the API that the client API, I think I sometimes call it, but I think it's a server API, which I've been corrected to, which is in either host core or wasmCloud host.
Yeah, the lattice controller API. Yeah, right now there is no code in wadm that converts the output of the reconciler into commands to be sent on the lattice control interface. That's just one of the other things that I need to implement, or that needs to be implemented in inside wadm.
Yeah, great. This is kind of the goal of bringing these kinds of ADRs and proposals up in the community meeting, is to get a good conversation around it. And Janetha, I know that you put a lot of work into kind of the structure of where wadm is today. So I'm glad you're here for it. All right, I think we're at our kind of open forum section of the community call. Does anybody have any general community call outs for the wasmCloud community, things going on, things that you're working on, or just the wasm community at large? Steve, you have a thing. Go ahead.
Hey, in a little over 2 weeks, there's KubeCon EU, the Cloud Native Computing Foundation conference in Spain, and there are a lot of wasmCloud talks there. Liam can give a better rundown than I can, but Brooks and Taylor are going to be doing a demo and keynote, and also I wanted to shout out Christoph Brewing is doing a talk on machine learning and wasmCloud on the Regex Day on May 14th. So if you're not going to be there in person, I think they usually show up on YouTube a couple of weeks after that, but there's gonna be some really cool talks and announcements there.
Yeah, I'll just dovetail on top of that, Steve. Thank you. We've got not only the Cloud Native Rejects, which starts on May 14th, which is Saturday. On Monday, May 16th, there are 2 talks, I think, that talk about wasmCloud. One is Bevy and wasmCloud, which is a game development framework from a group that is based out of Taiwan, I believe. The second is a talk from Adobe that will be doing a talk about some of the things that they're doing with wasmCloud. The talk on Saturday is from Christoph Brewing from BMW. He'll be doing a talk about the machine learning framework and some of the things that they've been working on. And then of course, Taylor and Brooks' talk, which is on Wednesday there. And we'll put the dates and times into Slack. Your KubeCon ticket includes a ticket to WASM Day this year if it's remote, so you can tune in on Monday and catch them before they hit YouTube, although they should hit YouTube within 3 weeks, I think is the sort of scheduled release time. If you're going to be joining us on site, let us know on Slack. We're planning a few events, maybe happy hour. You can join us there. We also have some meeting space out there, and there's a wasmCloud project booth this year as we sort of gear up towards applying for incubation later this year. Great call out, Steve.
Yeah, it's very exciting. And, thanks for calling that out now to give people a couple weeks, because I know that everybody here is going to book their ticket now that they know that we've got some wasmCloud talks on the schedule. I'm sure we'll, like Liam said, we'll drop it into Slack. And then as we get, the week before and the week of, we'll of course, update people as we're doing talks. All right. Any other general call outs? All right. Well, thank you everybody for coming. Great community meeting today. Great demos, great discussion. We'll keep this going. And I'll go ahead and stop recording. We can hang out a little bit afterwards.